Welcome back, guys, to video 2 in our mini-series on problem-solving strategies for problems involving mass, moles, and molecules conversions. In this video, we are going to examine a problem that requires us to convert between moles of a substance, and the number of individual atoms in that substance. Okay? Now, for all of these problems, I'm going to encourage you guys to take a two-step approach. In the first step, I want you to essentially read the problem, and I want you to identify what you're given and where you need to end up, and I want you to find which one of these formulas or collection of these formulas will be required to essentially take you from where you are, where you're starting, to where you want to go, but without actually doing any of the mathematics yet. So in this problem, we are given 0.025 moles of iron, and we're asked to determine how many atoms, individual atoms of iron, are present in that sample. So we're starting off here with moles of iron. Now our goal is to somehow convert moles of this substance into the individual atoms of iron. So what we then need to do is come over to our set of conversion factors here and figure out which one of these conversion factors carries out our desired conversion, moles to atoms. Well, you see our first conversion factor up here, Avogadro's number, does just that. 6.022 times 10 to the 23rd tells us the number of individual atoms or molecules in 1 mole. So the conversion factor we're going to be using here is nothing other than Avogadro's number, which we can go ahead and write out. It's going to be 6.022 times 10 to the 23rd. Now that we know how to carry out the conversion factor, step 2 is to actually perform the conversion. Okay? So in step 2 here, actually I'm going to give myself a little bit more room. We'll start over here, step 2. In step 2, we're going to start off with the given quantity. Actually write in the numerical value this time. 0.025 moles of iron. Now, we need to carry out a conversion that takes us from moles of iron to individual atoms of iron. Okay? This conversion factor, as we know, is going to be Avogadro's number. But this is a key step that many students will get confused on. So I want to take some time, because the question comes down to, well, do I put Avogadro's number in the numerator or in the denominator? Okay, you got a 50-50 chance. So what I encourage you to do, rather than roll the dice on this one, is really focus in on your units. We're in units of iron atoms here, or moles of iron atoms here. We want to get to individual iron atoms on the right-hand side, which means I need to multiply by a conversion factor that has moles of iron in the denominator. So I'm going to we'll put this guy in pink here. We want moles of iron atoms down there in the denominator, and then we want in the numerator units of atoms. Okay? And this way moles will cancel out and we'll be left with atoms. Now, once we've set up the units that we want, then we can go back to our conversion factor and be reminded then of what the actual numerical values are. Well, remember, Avogadro's number tells us the number of individual atoms in 1 mole of the substance. So I'm going to put 1 mole of the substance down here and then Avogadro's number up top. Now, all that's left to do is basically plug this into the calculator. 0.025 times Avogadro's number, and you should get a value of something about 1.5 times 10 to the 22nd iron atoms. So this is an example of how you can use Avogadro's number as a conversion factor to convert between atoms, and number of atoms or molecules, and moles of a substance. In the next video, we are going to explore how we can use the molar mass as a conversion factor to convert between moles of substance and a quantity of mass of substance in grams.